This here is one of the tougher questions we've seen from the digital SAT. And what we know right now is that the vertex is right here. So one thing to try is to use the vertex formula of a parabola, which would be, in our situation, a, which we don't know yet, x minus 9 squared minus 14. Because there's a minus sign for the x that just came from the formula, but the y actually was negative. So simplifying this a little, we have a times x minus 9 squared. And we can FOIL this out. First times first, x squared, outer times outer, minus 9x, inner times inner, minus 9x, and last times last, positive 81. And x squared minus 18x plus 81. And we have an a that was still there and a minus 14 that was still there. Now we're distributing the ax squared minus 18ax plus 81a minus 14. So we have that right there. That's what we have so far. Now, what are the a, b, and c? The a, b, and c in an ABC standard format. Well, this is the a of our quadratic, and this is the b of our quadratic. And last but not least, this right here is the c. So if we're doing a plus b plus c, that's the blue a plus the green b. So let's say minus 18a plus the orange c plus 81a minus 14. So combining some like terms, we have 81 minus 18 plus 1, because this is 1a right here. And that gives you 64a minus 14. So they asked us for a plus b plus c, and we put it all together, and we got 64a minus 14. Now, another thing we need to know about this question, because the vertex is at 9, negative 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The vertex is right around there. And we see that it hits the x-axis at 2 points. That tells you one thing. That tells you that the a term right here has to be positive. So 2 y-intercepts, that means that it's upward opening. If you didn't have any y-intercepts, then the parabola would look like that, and we would know it would be downward opening. But we know it's upward opening, and an upward opening parabola has a positive a coefficient. So the a coefficient has to be greater than 0. Seems pretty random, but in this incredibly tough question, we're being offered options for a plus b plus c. In other words, looking at the 4 answer choices, they're each telling us a plus b plus c, which is what we got, 64a minus 14, equals all 4 of these numbers. Minus 23 equals 64a minus 14, negative 19, 64a minus 14. So we're being given all these things that are, one of them is supposed to be correct in saying that it's equal to the a plus b plus c, which is the 64a minus 14. And the only apparent thing that needs to be satisfied in all of this is which of these is going to work out so that a equals 0. A is greater than 0. It's not equal to 0, it's greater. So for which of these answer choices, when you go ahead and solve that out, does A work out to a positive number? So let's solve them all out and find out. If we add 23 to both sides here, or actually if we add 14 to both sides, we'll get -9 equals 64A, and A is -9 over 64, which is negative. If we add 14 here, we get -5 equals 64A divided by 64, and A is -5 over 64. If we add 14 to both sides here, we'll have 0 equals 64A divided by 64, and A equals 0, which is close, but we actually need it to really be negative. And that is going to be this last answer choice. If we add 14 to both sides, we get 2 equals 64A divided by 64, and you get A is 1 over 32, which is a positive number, and that is our answer. So this will be correct, which is D for this question.